right, we're starting day 6. I have the day 5 paper on here just to quickly review what we did yesterday. Remember that we learned the circumcenter of a triangle is the point where all 3 perpendicular bisectors meet. You draw your perpendicular bisectors, they have an intersection point at the circumcenter. We learned that when you draw your angle bisectors from each vertex of the triangle, they meet at one point called the incenter. Today, we're going to learn a new term called the centroid. So, what is a median of a triangle? Hopefully you guys remember this from earlier in the year when we did this. The median of a triangle is formed by connecting the midpoint of one side to the vertex of the opposite side. Now we know from working these constructions for the past week how to find the midpoint of a line segment. So we're going to find the midpoint of each side, connect those to the opposite vertex, and see what we end up with. So to find the midpoint, I put my point of my compass on the endpoint of one of my line segments. I'm starting with AC. I make sure it's more than halfway because I want to make sure I have room for my arcs to cross each other. And go over to C. Same thing, which I didn't bring that one down quite far enough. I'm setting this up just like I do a perpendicular bisector because that's what gives me the halfway point on my line, remember? So if I line this up like this right here should be the midpoint of my line, exactly halfway between A and C. So if I go ahead and connect that point to the vertex over at angle B, that's one of my median lines. Okay, let me do all 3 sides. Switch over here to BC. The midpoint of BC. So I'm going to go ahead and make the median. I'm going to make it from that point to the vertex over at angle A. Okay, the only one I haven't done yet is this little part AB. I can probably shrink my compass in a little bit. Okay. Line up perfect, I think. So that's going to be my midpoint right there. I'm going from that midpoint over to my vertex at angle C. They lined up perfect, so I did a good job. Okay, at my midpoints. All right, they're all going exactly through this point right here. So that point where those intersect is called my centroid. Okay. All right. After finding the centroid, label the midpoint of AB. So I'm going to label this point Z right here. Label the midpoint of BCX. So this point right here is going to be X. Label the midpoint of AC, point Y. So that's this point right here is Y. And label the centroid point P. Okay. Does P look like it's closer to each vertex or closer to each side of the triangle? Well, when I look at this line segment BY and see where my centroid is on there, doesn't it look, I think PY looks shorter than BP, and I think PX looks shorter than PA, and I think PZ looks shorter than PC. So I'm going to say it's closer to each side rather than the vertex, because that little segment on the way to the side looks shorter than that segment on the way to the angle. Okay, the centroid theorem says the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. Okay, so that's saying from this vertex to this midpoint, the centroid is 2/3 of the way along that line. So that means this is 2/3 of the way, and this is 1/3. Okay. All right, let's remember this theorem, centroid theorem. This point is 2/3 of the way along that line. Let's write 3 equations that we know from this theorem using our triangle. Okay, well, what did we just say? CP is 2/3 of the way along, and ZP is 1/3 of the way along for this whole line segment CZ. So what are 3 equations we can write? We can write CP is 2/3 of CZ. We could also write from that same thing that PZ is 1/3 of CZ. We can pick another one of these lines. We can say AP is 2/3 of AX. We can look at another line. We can say BP is 2/3 of BY. Okay. This is the main idea of the 3 equations that we get from our theorem. The centroid is 2/3 the distance from the vertex to the opposite side. Okay. If O is the centroid of this triangle DEF, and DO is 8, and HE is 15, that's this whole thing, and OI is 4 1/3, that's this little segment. Find each of the following lengths. We could find all of these lengths with the information we're given here. Okay, so if DO is 8, and we're supposed to find DG, that's this whole length from the vertex to the midpoint. Okay, so if 8 is 2/3 of the length, 2/3 of DG is 8, then what is all of DG? Well, I'm just gonna kind of think about that. If this is 2/3 is 8, that means 1/3 is 4. This has to be 4 because it's 1/3. So what's the whole length is gonna be 12. Or I can do it algebraically if I'm don't have my brain turned on yet this morning. I can say I can multiply both sides times 3/2 to make that 2/3 cancel out. And I'll end up with DG is 2/3 of 8 times 2 is, what did I just do wrong? I'll multiply by 2/3 instead of 3/2. My original equation was 2/3 of DG, so if I want to get rid of 2/3, I got to multiply by 3/2. Sorry for that little mistake, guys. 3 times 8 is 24. 24 divided by 2 is 12. Okay, we could do it algebraically like that. I prefer to just realize that if 8 is 2/3, that means 1/3 is 4. That means 8 plus 4 is 12. That's me. OG, oh, okay, we already found that. OG is going to be 4, right? Because it's 1/3 of 12. Is 1/3 of DG, and DG is 12. 1/3 of 12 is 4. If you prefer to do it algebraically. OE, I really want you guys to just think about these things and not have to do all the algebra. OE, what does that equal? We were told that HE was 15 and OE is 2/3 of HE. So OE is 2/3 of 15. That would be 10. 2 times 15 is 30, divided by 3 is 10. I could also think if all of this is 15, 1/3 is 5, 2/3 is 10. FI is this whole length. Okay, OI is 4 1/3. If 4 1/3 is 1/3 of it, then that means this part is going to be 8 2/3. If I add those together to get my total, 8 and 4 is 12, 2/3 plus 1/3 is 1, so FI is 13. Use graph paper to graph the triangle and find the centroid of triangle JKL with vertices at J is -9, 1, K is -1, 5, and L is -5, 9. Give the coordinates of the centroid. I kind of don't want to do this one for you guys. I really would like for you to do it by yourself. But I will tell you, when you start drawing it out, it's going to be really obvious. You're not going to need to pull out your compass to find the midpoints of the lines because you're going to be able to count it out on the graph paper. So I want to let you see what you can come up with on that one yourself without me showing you. Number 3, go back to the triangle we used on page 1 to construct the centroid. Use your ruler and measure as close as you can in centimeters to see if the centroid theorem holds true with your triangle. So it mattered if I was accurate or not here. I'm going to try to measure in centimeters and test this thing out. Let's test out, does CP really equal 2/3 of CZ? And you're going to do this for all 3 of your lengths, but let me just do it for 1 for you. Okay, let's come up with what CZ is as best as I can measure. I know I'm not going to be super accurate. I need some sort of laser measuring tool, but the best I can do here, I think that's 11.1 maybe. I'm going to use wiggly lines since it's approximately 11.1. And then let's find out what CP is. CP. Looks like, 7.4 maybe? CP is approximately 7.4. Let's try this out. Is CP equal to 2/3 of CZ? Is 7.4 roughly 2/3 of 11.1? Again, don't expect perfection here. But let's try it. 11.1 times 2/3 is 7.4. Yes. Erase my little question mark and put a check mark. That does check out. And then I want you guys to go ahead and try it for all 3 of your medians, not just CZ, but also go back and do AX and BY. Okay,